Hello, everyone. In the simple smart home system designed by us, alarm prompt will be given when the combustible gas content exceeds the standard, or someone illegally enters the room in anti-theft mode. Therefore, we will learn about the design of sound and light alarm circuit in this lesson. Through this lesson, we'll be able to know about the composition of the sound and light alarm circuit and choose the correct components and parts according to the actual demand. The key point of this lesson is the composition of the sound and light alarm circuit, and its difficult point is how to correctly choose the models of the components. In this lesson, we're going to design an alarm circuit that can give prompt by sound and light flashing. The sound and light alarm circuit is composed of three major parts: transistor relay driver circuit, light alarm circuit, and sound alarm circuit. Among them, the function of the transistor relay driver circuit is to control the switching on and off of the relay by use of the switching action of the transistor. The function of the light alarm circuit is to generate the lighting effect of flashing alternately. The function of the sound alarm is to generate the alarm sound. After determining the composition of the system, we still need to determine how to realize the circuit function. In the transistor-driven relay circuit, since the low-level output capability of the 51 microcontroller's I/O port is often stronger than its high-level output capability, and considering the power-up state. In order to avoid misoperation of the relay at the moment of power-up, it is more advantageous to adopt a negative logic low-level drive design. Therefore, this project uses a PNP-type transistor to drive the relay circuit. The light alarm circuit applies a typical astable multivibrator circuit to generate the rectangular waveform, which controls the alternate flashing of two indicator lights. Its working principle is as follows. When transistor Q1 is turned on, the voltage on the left side of capacitor C1 becomes 0 volts. Since the voltage across the capacitor cannot change suddenly, the voltage on the right side also becomes 0 volts, causing transistor Q2 to be cut off. At this time, LED D1 lights up, and capacitor C1 is in a discharging state, while LED D2 is off, and capacitor C2 is in a charging state. After capacitor C1 completes discharging and starts to charge in reverse, when the voltage on its right side rises to 0.7 volts, transistor D2 turns on, the voltage across capacitor C2 becomes 0 volts, forcing transistor Q1 to be cut off. At this time, LED D2 lights up, capacitor C2 is in a discharging state, LED D1 is off, and capacitor C1 is in a charging state. With the charging and discharging of the two capacitors, the two LEDs alternately flash. It should be noted that if the capacitance of two capacitors is different, the charge and discharge time will be inconsistent, which will lead to the different flashing frequencies of two LED lights. The sound alarm circuit is composed of two different types of transistors, speakers, capacitors, and resistors. This circuit is a complementary self-excited multivibrator circuit. Its operating principle is as follows. When the switch turns on, transistor VT1 is on to provide the base current of transistor VT2 with a path, while decreasing the VT2 base current. This allows VT2 to conduct, driving the speaker to produce sound and charging the electrolytic capacitor C1. When the voltage across C1 approaches the supply voltage, its polarity becomes negative on the left and positive on the right, causing both VT1 and VT2 to cut off. Yet, since capacitor C1 continues to supply power to the speaker remains the sound-producing state and stops working until capacitor C1 finishes discharging. Then the circuit resumes its original state and enters the next period of oscillation. Now, we've determined the basic frame of sound and light alarm circuit. After that, we still need to correctly choose the components before completing the final design of the circuit. The current during the working of 5 volts relay is about 50 mA 80 mA, so we choose 9012 transistor with a maximum collector current of 500 mA as the drive of the relay to realize the relay switch functions. The light alarm circuit uses two 9011 transistors to produce oscillatory wave in conjunction with the peripheral circuit. The current during the working of the horn of the sound alarm circuit is about 100 mA to 300 mA, so it is often very difficult to drive a single transistor. Therefore, it is necessary to use 9011 and 9012 to form Darlington tube to increase the drivability and adjust the effect of the alarm sound in conjunction with the peripheral circuit. Now, we've completed the design of the sound and light alarm circuit. Through this lesson, we've learned that the sound and light alarm consists of 3 parts: electrical switch, sound alarm, and light alarm. Also, we've chosen the components like transistors, intermediate relays, resistors, and capacitors according to requirements. That's the end of this lesson. Thank you for watching.